Welcome back, viewers. In the second question, we want to look at a question on statistics, and we want to plot an Ogive curve from Ungrouped data. So the table below shows marks scored by 42 students in a test. So starting with the mark of 25 and using equal class intervals of 10, make a frequency distribution table. On part B, on the grid provided, draw the Ogive for the data. In part C, Roman 1, using the graph in B above, estimate the median mark, and finally the upper quartile mark. To make a frequency distribution table, you'll need a table with 3 columns. The first column, you'll need the class. The second column, you'll need the tally column. And then the third column, you'll need the frequency column, like that. Now we have been told to use a class interval of 10. What does this mean? Starting from 25, our bin where we shall distribute the data up to the next level, we should have a class interval of 10. So for us to have a class interval of 10, it means when we take the upper limit minus the lower limit value, we should get a value of 10. So if our first value is 25 here, our lower limit will be 24.5, and our upper limit, this will be our lower limit. So our upper limit should be equal to, when we add 10, our upper limit should be equal to 34.5. So this will be our upper limit. So from 25, the next value should be 34. So that when we get the upper limit in 34, it will give us 34.5. The lower limit in 25, it will give us 24.5. So our first class will run from 25 to 34. So the next class from 34 will go to 35 to 44, and then the classes will run in that order. So we go back to our data, look at the maximum value for the data. If you go back to the data, our minimum value for the data, I think, will be given by 25, and our maximum value for the data, from what we have, I can see we have 86, 81. Yes, our maximum value for the data will be 86. So we run the classes up to what captures 86 and above. So 25 to 34, 35 to 44, 45 to 54, 55 to 64, and then 65 to 74, 75 to 84, and then 85 to 94. We have now captured the classes as required. Now we need to make the frequency distribution table. So we go back to the raw data and then put the data into the classes now. Distribute the data into the classes. And the easiest way to do this is to cancel out the values when we capture them into the given classes. So we start with 25 to 34. We shall do it column wise. Anything that falls between 25 and 34. So we start capturing. So we have one value there. The second value is here. The third value is here. Fourth value is there. So I don't think there is any other value remaining. So we come and tally 4 of them, and we're going to use strokes. 1, 2, 3, 4. And in our frequency column, we're going to write the numeral or the digit 4, like that. So between 35 and 44, 35 and 44, we go back to the data. We have 1, 2, 3, 4, 5. I think there are 5. So again, here we do 5 strokes. 1, 2, 3, 4. And for the fifth one, we close that bunch and write here 5. 45 and 54. 45 and 54. We have 1, 2, 3, 4, 5, 6, 7, 8. So we come 1, 2, 3, 4, 5, 1, 2, 3. And here we write 8. Between 55 and 64, 55 and 64, we now continue. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1, 2. Numerical value 12. Between 65 and 74, we go now for 65 and 74. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So on our tally, we come and tally 9. 1, 2, 3, 4, 5. 1, 2, 3, 4. Numerical value 9. And then between 75 and 84, 75 and 84, you have 1, 2, 3. So 75 and 84, we have 3. 1, 2, 3. Numerical value, you write 3. 85 and 94. Between 85 and 94, so we have 1, so we only have 1 value. So we tally with a stroke, and the numerical value we write 1. After that, you must close your table by giving the numerical value for the total. So below here, you must write the total and you add up all this. So you can confirm using your calculator. That will be 9, 17, 29, 38, 41 plus 1, 42. It is important for you to get the distribution table right. You must close with the total at the bottom. So that is how you make a frequency distribution table. A frequency distribution table is made like that. In the next question, on the grid provided, draw the ogive for the data. On the grid provided, draw an ogive curve for the data. So for us to draw an ogive curve, we need to come up with another column, the cumulative frequency column. And the cumulative frequency column, you can just do it on the same table, is a total of the running frequencies. A total for the running frequencies that we have. So we start with 4. 4 plus 5 gives you 9. 9 plus 8 gives you 17. 17 plus 12 gives you 29. 29 plus 9 gives you 38. 38 plus 3 gives you 41. 41 plus 1 gives you 42. So in our graph paper, we need to remember what to plot. On the y-axis, we shall get our graph paper. Just reminding you, on the y-axis, we are going to plot the cumulative frequencies, and then on the x-axis, we are going to plot the max. Normally, most of the candidates mess up by plotting the upper class boundaries on the x-axis. It should be the max. You should plot the max against the cumulative frequencies. And most important, don't forget to get an appropriate scale. An appropriate scale for your Ogive curve. And then when we plot the cumulative frequencies against the max, and the max will be given by the upper boundaries. Upper boundaries. Our upper boundaries, in this particular case, we are going to get the upper boundaries for the classes. So upper boundaries will have 34.5, 44.5, 54.5, 64.5, 74.5, 84.5, and 94.5. So upper boundaries, I don't think we're going to forget that, but if you have space, you can write here the upper boundaries or the max for that particular case on your graph. So using our graph paper, or using our grid, of course the grid will be provided to you by the examiner, so don't need to worry about this. We have seen that from our first class. We have seen that from our first class, the lower mark will be 34.5 and the upper mark will be 94.5 on the x-axis. So in most cases, students normally plot the Ogive curve and it hangs. In this particular scenario, for us to avoid it hanging, our lowest mark, 34.5, will start exactly at where 0 is on the Cartesian plane, so that we don't break our graph and the Ogive curve doesn't hang. We are going to see what I mean by that. And then our greatest value on the y-axis, our cumulative frequency will be 42. So the most appropriate scale that we can pick here, so that our graph doesn't look tiny, we can get our scale. And on the x-axis, let us get 1 centimeter to represent 5 marks. And then on the y-axis, 1 centimeter to represent 5 units. When you get your scale and write it like that, of course, you will earn a mark for that. Now we can get our ruler and draw the required axis. Get our ruler, draw the required axis. The x on the y-axis. That is the x-axis, and this will be our y-axis. So 0, 5 can label, 10, 15, 20, 25, 30, 35, 40, 45. And then for the marks, remember we said this one will be the cumulative frequency, and here we shall have our marks on the x-axis. So 0 on the x-axis, 1 centimeter we've said represents 5 marks. So we'll start from 0, and our 34.5 will be exactly on the x-axis to avoid our graph hanging. So we'll write 34.5. So after every 1 centimeter, 5 marks. So this will be 39.5. The next value, 44.5, followed by 54.5, next 64.5, next 74.5, 84.5, and 94.5. Don't forget to write here the marks. So, as I have told you earlier, most students will write here upper class limit or upper boundaries, which is wrong. Now we go back to our table and now plot the value of the cumulative frequencies against the upper class boundaries or the marks for that particular matter. Now 30.5 will be plotted against 4. 34.5 against 4. So on the y-axis, every 2 small squares will represent 1 unit. So 4 will be 2 squares below 5. 2 small squares below 5. So put a mark 34.5 at 4. 4 is there. Put a mark there. At 44.5, our value is 9. At 44.5, our value is 9. 44.5, 9. Again, 9 will be at 2 small squares below 10. Put a mark there. The next value, 54.5, it will be at 8. So 54.5, plot it at 17, not 8. 54.5, it will be at 17. 17 will be 4 small squares above 15. 4 small squares or 1 small square just below that other value, which could be 17.5, just below that by a single square. At 64.5, plot 29. At 64.5, we're going to plot 29. So here is where we are. 64.5, 29. So 64.5, 29. 29 will be 2 small squares below 30. 2 small squares below 30. Plot that. And then at 74.5, we're going to plot 38. 74.5, 38. 74.5. 74.5 is here. We move upwards and plot 38. 38 will be given by 4 small squares below 40. 4 small squares below 40. 38 there. And then at 84.5, 84.5, we're going to plot 41. So 84.5, plot 41, 2 small squares above 40. That is done. And then at 94.5, we're going to plot 42. At 94.5, we're going to plot 42. So 94.5, we're going to plot 42. 42 will be at 4 squares above 40. 4 squares above 40, just 1 square below 42.5. So 4 squares just up there. Bear with me, my writing almost captured where the graph is, but we now need to look at the trend of the points. If you follow that trend carefully, it forms an S-shaped curve. Therefore, you now join these points using a smooth curve. Join them using a smooth curve. Until you reach the end point, like that. So that is our ogive curve. So the axis, both axes will earn you marks, the scale will earn you a mark, and plotting the points and drawing a smooth curve will also earn you a mark. In part C, we are told, using the graph in B above, estimate the median mark, and 2, the upper quartile mark. So we want to use our graph. We want to use our graph 1 to estimate the median, and 2, to get the upper quartile, normally abbreviated by Q3, upper quartile. So for us to get the median, we know that the median in this particular case is the data or the position that will divide our data into 2 equal halves. So when we get n over 2, this will give us 42 divided by 2, which gives us 21. So we need that position which divides our data into 2 halves, 21 on the left hand side and 21 on the right hand side. So that particular position will be given by, for us to get that position, it means it lies between 21 or 21st and the 22nd position, between the 21st and the 22nd position. And this value will now be given by what? It will be given by 20. Yes, the position of that value will be at 21.5th position of our cumulative frequency, so that we can get the median. So when we go back to our graph, when we go back to our Ogive, we need to get the position where 21.5 lies. So every 2 squares will represent 1 unit. So 21.5 will lie at the third small square. So the third small square, we need now to get our ruler after the third small square, which is, you can count 1, 2, 3, which is there, and then get your ruler, draw a horizontal line, must be very careful and accurate, like that. Where it cuts your graph, drop a perpendicular, and according to our outcome, we are getting it between 54.5 and 64.5. That is after 5 units. So our median in this particular case, we can say our median will be given by this is a value from our graph. When we read this value, it will be approximately equal to 59.5 marks. Normally, your level of accuracy should be plus or minus 0.1, plus or minus 0.1, according to the level of accuracy that the examiner will give in this particular case. So in this particular case, 0.1 cannot actually be very feasible, but plus or minus 1.0, plus or minus 1.0, not 0.1 in this particular case. Now, in the next question, we want to get the upper quartile. So the upper quartile will be given by the position of 3/4 of the data that we have. And this position, when you simplify that, you're going to get at the 31.5th position, at the 31.5th position. So we again go back to our graph, get where 35.1 is. So 31.5 will be after 3 small squares after where 30 is. So again we come and identify 3 small squares, will be up here, and then using our ruler we again draw a horizontal line to cut our graph at a point. Draw a horizontal line. Like that. And then drop a perpendicular. Drop a perpendicular to the x-axis. Drop a perpendicular to the x-axis like that. And we now read off the value at the x-axis. We now read off the value at the x-axis. And if we read the value at the x-axis, they are almost 2 squares before 5. 2 squares before the value of 5 in 1 centimeter. So using our scale, we said 1 centimeter to represent, we said 1 centimeter is going to represent 5 marks on the horizontal axis. Therefore, one small square here, one small square is going to represent 0.5 units. 0.5 units. So one small square, a tiny green small square, is going to represent 0.5 units. And because now we have 3 of them, 3 small squares after 64.5. So we're going to say 0.5 multiplied by the 3, which gives us 1.5 units. 1.5 units. So for us now to get this value of our upper quartile, we are going to get 64.5. Upper quartile now will be given by 64.5 plus 1.5 plus 1.5. So this will give us an approximate value of that is 0. This is 666. An approximate value of 66. And as I told you earlier, this will be given an allowance of plus or minus 1.0, plus or minus 1.0 from the exact answer. So if you fall within the range, you're going to get it right. Now I just want to go out a bit, not out a bit, but in such a question, you may also be required, or the examiner may ask you to calculate the semi-interquartile range. The semi-interquartile range. So how would you go about calculating the semi-interquartile range? The semi-interquartile range is given by the upper quartile minus the lower quartile divided by 2. Upper quartile minus the lower quartile divided by 2. We already have our upper quartile. We need to go back to the graph and get the lower quartile. The lower quartile will be given by what position of the data? The lower quartile will be given by a quarter multiplied by 42, and we get that position. So the position will be given by the 10.5th position. So we're talking about the 10.5th position on our graph. So we come back to our graph. 10.5th position will be given by, at 10, after the first small green square. So that is where 10.5 will be. We have put a mark. And then you get your ruler, draw a horizontal line, draw a horizontal line after that square, and then read off the value, draw a vertical line, to read off that value after 44.5. So after 44.5, we are going to have 5 small squares, and this value will now be given by 0.5 multiplied by 5, which is equals to 2.5. So our lower quartile will be 44.5 plus 2.5, which gives us, can work out that 44.5 plus 2.5, which gives us 47. So our lower quartile, Q1 will be equal to 47. So to get our semi-interquartile range, we're going to get 66 minus 47 divided by 2. Work out that. I hope you got a value of 9.5. So that is how you can also calculate the semi-interquartile range in case you are asked to do so by the examiner. So thank you for watching. Kindly like, subscribe, and share.